We are live, so we can start the session.
So, Sukrat, can we start with BDM? Perhaps you can play the course orientation video by Professor GV, and then we can move on to business analytics, followed by tools for data science. Is that okay?
Sure, sir. Can we, will we have more students on the call?
So I don't think so. I don't see anybody joining. It's going to be a discussion between the instructors, and we also have a Google Sheet where students have asked their specific questions.
Okay.
Perhaps after the video, I can read out the questions one by one, and if possible, you can answer them.
Sure, sir. Give me a minute.
Sure, sure.
Is it visible, sir?
Course.
Yes.
Data
Audible too?
Yes. Very increase the sound a bit.
For managing businesses using data would probably be like
Your system sound.
people, quite a few people. The first 4 weeks.
Now it is not audible.
Sir, is there any issue with it? I'm not able to hear it.
Initially, I was able to hear that. Now it's like it is not even audible. Previously, the sound was low, but now it is not even audible.
Okay, give me 1 second.
Really what the course content is about, you will find out is about
It's audible
managing
now.
businesses using data would probably be a better title.
Yeah, proper.
People, in fact, quite a few people. The first 4 weeks is going to cover the business context, which comes mostly from the world of economics. So along with me, my name is Venkatesh. So along with me, and I'm just called GV, right? So you'll hear GV being referred to quite a lot and as we go along. We have Suresh Babu, who is a professor of economics at IIT Madras, and he will be sharing the load of teaching the first 4 weeks, or we both will be discussing really concepts from economics in the first 4 weeks. Subsequent to that, we have a bunch of case studies that I will go through. I will explain to you what we are going to do, which will be for the remaining, for 7 weeks we have case studies, very interesting case studies from 4 different domains. And to help me with those case studies, I have Dr. Milind Gande, who is at IIIT Bangalore. He is the head of the Machine Intelligence and Robotics Center there. He has many years of industrial experience and understands this world also of data very well. So Milind Gande and I will be taking the next 7 weeks. So between myself, Suresh Babu and Milind Gande will try and get you a reasonable coverage of what we want to do in this course. But the case studies itself, we are going to have some guests, right, who are going to basically help us with the case study. So from Flipkart, we have Omkar Karandikar, who is heading the logistics division in Flipkart, and he is going to basically help us with the kind of a fictitious case you have created, but based on data that is you can see in Flipkart. So this is called Mart. That's a case that we have, and then we are going to have a manufacturing case that basically for which we have a person, Shivakumar, who's got many years of experience in the manufacturing industry, and he's been consulting in manufacturing and so on. So he will basically be helping us with the data as well as the discussions on that case. And then we have Varsha from Mercer. Mercer Consulting is a very prominent, well-known HR consulting firm. So she is going to help us with the case in HR. And finally, we have Venkat, who is going to basically, who is from PayPal, who is helping us with the case on payments, fintech. So we have 4 different kinds of cases. I'll quickly explain to you what we want to do in this course. The learning objectives basically are, just like in some sense the computational thinking course got you inducted into the world of computing, starting from the thing that basically one assumes that there is no background. I mean, we are assuming that you don't know anything in computing, and we are kind of trying to introduce you to the world of computing. So also this course is a kind of induction into the world of business. So we are assuming that you probably don't know anything about business, and we are trying to induct you into the world of business, and trying to do that very fast, right? In some sense, because we have only 12 weeks to do it. So we're trying to do that very fast. But again, just like in the computational thinking course, there is a slight variation we have put on the content, in the sense that this is coming from the lens of a data scientist. So just like in computational thinking, we try to introduce computation from the view of a data scientist through the lines of data. Here also we are trying to introduce you to the world of business through the lens of data. So that is how it is, in some sense, very different from what you might find in other places. Okay, so the learning objectives of this course, what we expect that you will learn are to understand the business context, which means understand how consumers consume, what do they consume, what kind of data do you look at to figure out consumption patterns, and underlying these consumption patterns, there are some concepts, fundamental concepts that are lying around, microeconomic concepts, like the demand supply curve and things like that, the elasticity of demand, how does demand vary, or how does consumption vary with price or with income or something like that. So how do we look at consumption patterns, and how do we look at the relationship of consumption patterns to other variables like income or price or some other determinants of consumption. And then we look at the supply side issues like production, the cost of production, how do you manage the cost of production, what do firms optimize, how do they optimize, under what conditions do they optimize, these kind of things we will look at in the first 4 weeks. Beyond that, we start looking at the analysis of data that is coming from a firm. So typical accounting data that the firm produces is in the nature of profit and loss statements, the balance sheets of the firm, the cash flow statements of the firm, and other information, operational information that the firm provides. How do we take all this information and make some sense of the firm itself, how competitive it is, whether it is growing, is it profitable, is it managing its cash well, things like that. But also we try to position the firm within its industry. So industry basically is a collection of firms who are competing for market share. So how do we look at the competition that is going on in the industry, and whether that firm itself or the industry itself is well located, in the sense that is it getting too much pressure from suppliers, is it getting too much pressure from customers, is it under threat of being substituted away its products, and so on. These kind of things that we will discuss in terms of analyzing the firm level and industry level data and putting the two together to get a composite picture of a firm. So this constitutes the first 4 weeks, and we will basically give you a chance to work on many of these things on your own through assignments. Okay, I will discuss a little bit more as we go along. Then we then go to the case studies. We discuss how businesses operate. So what exactly goes on inside a business? What are the business functions that are there? What is the role and responsibility of each of these functions? And specifically, how do businesses manage their functions through data dashboards? So every business typically has some key performance areas that they have to manage, and there are some measurements of these key performances, KPIs they're called. And how do they, and for these you need to generate data and present this data in some meaningful way. So how do businesses manage using data? This is what we will be discussing. And to manage using data, first you have to get the data, right? So where is the raw data stored inside an organization? In what form is it made available for analysis typically? And so we will actually be looking at live data that come from organizations from various disciplines in the organization like manufacturing, sales, accounting and so on, and try and use some simple techniques to make sense of this data, right? To process this data, organize this data, and to present this data using some charts so that it starting to make some meaning, right, out of it. And through this process, we hope that you will come away with some really good skills on the use of worksheets, Excel or Google Sheets or any form of spreadsheet, how to use it well to organize your data. So in this course, the data sets we will have will be reasonably small. I mean, it will be 1,000, 2,000, 3,000 entries, not too many, so that we can work with Excel, right? In other courses, you will probably be working with much larger data sets and which may require you to write software and process it using some statistical software and so on. So we don't have much statistics. We are not going to do any statistics in this course. It's mainly basically looking at the raw data, organizing the raw data in the form of a spreadsheet, and then pulling the data into different what are called pivot tables, and then using these pivot tables to organize basically the information in some way, then drawing some charts from it and making meaning out of it. This is what we will be doing in this course. And the way we will be delivering this course basically is through a mix of conceptual lectures, which you will see mainly in the first 4 weeks, which will be tested using quizzes. We will have presentations of case studies, and why we do that, we'll basically be doing working illustrations. So we'll actually be working through those case studies with data, and we will be giving you mini assignments, quite a few of them, so that you have a chance to work on these data sets on your own and submit the results, which we will evaluate. And finally, I will discuss with you a course project. So we have, for every student, we expect basically you will work on a project of your own, where you will try and collect some field data from some relevant enterprise, small enterprise, and you will try and organize that data of that enterprise in the way in which we are discussing some of the issues in the case studies that we will be presenting to you. So hopefully with all this, you will come away at the end getting a good understanding of how businesses are structured, how they are run, what kind of data they generate, what is the thing they do with the data, what do they do with the data in terms of organizing the data and then converting that organization into some presentations that they can make to their management and so on. So this is what we hope you will come away with, a fair amount of skills on managing businesses. Now, much of this content that we are doing in this course is coming from various sources. Okay, it's not from one book, it's not from one topic, one course or anything like that. So we have material that is taken from the subject of micro and macroeconomics. We have material that is taken from what is traditionally in the finance and accounting courses. We have something coming from the marketing and strategy courses in a business management degree. We have something coming from production, operations management, scheduling, things like that. And finally, we have something coming from management information systems type of area. So these are very diverse, different things. Each of them probably is a full course, and we have picked a little bit here and there, and we have tried to put it together into a course. So it might look a little bit ad hoc, but please bear for the course. We are suggesting a couple of pointers. You can take a look at them, but you will not find what we are teaching in this course in those books directly, right? So unless we write a book, which we plan to do and share it with you, there is no single book which gives you this material directly. So you have to make best use of all the material we are distributing in the course. And if you have any questions, feel free to write to us, and then we can try and answer your questions. Okay, with that, I want to talk a little bit, go into a little bit of depth into what we are doing week-wise. Okay, in the first week and the second week, we will be discussing consumption and demand and the microeconomic concepts underlying consumption and demand. Okay, so of course there will be a tutorial on spreadsheets which somebody will give you, so you know how to use spreadsheets and Google Sheets and so on, because throughout this course we are going to use it liberally. So you need to get a good handle of how to use a spreadsheet yourself. So that we will be giving you as a prelude. So we expect that you know it before we get into this first course, but we are going to give you a small tutorial on that. But in the first week we will be discussing the consumption. So we are basically discussing the how organizes the world, or how economists take a look at the world in terms of different agents, right? And this basically the two agents that are very significant for us in economics. One is the producers, the firms, and the consumers, that is you and me, households basically who are consuming. So on one side, firms are producing the goods and services that the households consume. On the other side, the households are providing the capital and labor that the firms consume. So in some sense, there is a kind of a circular diagram that you can draw between firms on one side and consumers on the other side. And basically there is a flow of goods and services from firm to consumers, and there's a flow of labor and capital from the consumers to the firms. And this flow basically in some sense depicts the world's economic model. And we are trying to figure out how to organize this economic model in a way that it is efficient, right? So economists like to believe that price as a mechanism shifts or makes allocation of resources in this model efficient. All these kind of things we will be discussing in week 1. What is consumption? What is production? What is this business of exchange that goes on between producers and consumers? What are the different kinds of consumption baskets that we can find? Like different households with different incomes, they consume different things. So how does one take a look at the data that is generated from a consumption survey, for example? And there are sources of customer survey data that are available, like National Sample Survey, which is produced by the Ministry of Statistics in India. How do you look at that? How do you make sense out of that? Or other survey forms, like for example, the Center for Monitoring Indian Economy has something called Consumer Pyramid Household Survey, CPHS, which is much more frequent. How do we look at that data and make sense out of it? Or some other kinds of survey data that are generated by consulting companies. This is what we will look at in week 1. Basically, the idea is to get your head around this whole idea of consumption, and where do you look for data on consumption, and how do you make sense out of that data. Week 2 is about the various underlying theoretical concepts that are there in understanding economy, right? So the first theoretical principle is that of utility, right? So customer satisfaction, when you buy and consume something, you gain some satisfaction, and that is expressed by economists using this thing called utility. And utility can be cardinal, which means it can be measured, or ordinal, which just can be ranked. So we look at both cardinal and ordinal utility and the idea of indifference curves. Then we look at this business of drawing a demand curve by aggregating the consumption pattern of several households, drawing the supply curve by aggregating the production of various firms, and how basically these two curves, that is the demand and supply curves, interact via the price mechanism. And then we talk about how demand changes with various things like income and price and so on. And that business of changing of demand with various things is called elasticity of demand. And so the various factors of elasticity and what it means is what we will discuss in week 2. Simultaneously, on the other side, just like we do consumption, we look at production and look at cost curves, production cost curves, and try and figure out how you can make decisions on how much to produce, what quantity to produce, and maybe what kind of prices you should sell your goods at, and so on, pricing decisions and so on. How do you make those kind of decisions? By looking at some curves, right? So that basically constitutes the material for weeks 1 and 2. In weeks 3 and 4, we are going to get into analysis of data coming out of the firms, right? So in week 3, we will be looking at firm level performance data, and in week 4, we will be looking at industry level performance data. So first we discuss pricing strategies of firms in week 3, and then we take 4 specific companies. Ultratech, which is a cement company, so it's from the cement industry. Page Industries, which is a textile company, so it makes, we all wear jockey, right, innerwear and so on. That is Page Industries. Nestle, which makes consumer products, FMCG products, like it's a leading thing, in many categories of food products. And TCS, as we all know, is an IT company. So we have from 4 different industry segments: cement, textile, FMCG, and IT. We have 4 companies. So first we will analyze the firms in week 3, and then we will look at the industry structure in week 4. Now, before we discuss the industry structure in week 4, we give you a framework within which you can understand industry structure. So how do you first of all classify industries? What are the ways to classify industries? So there is this thing called national NIC codes, right, which basically gives codes to every company, every industry. So how does this classification code come about? And the data that is generated by inspecting factories government publishes this data. So how do you look at that data? Then there is this thing called index of industrial production, which gives you high frequency data. Every month you can find out every sector, what kind of production is happening in that sector across the country. So how do you look at IIP data? How do you look at PMI data, which is called Purchasing Managers Index, sentiment data, right? So these kinds of indices tells you a fair amount of gives you a fair amount of information about how an industry is performing. But even within that, you have to still do some analysis of where a firm or a specific industry is located vis-a-vis other industries that are around it. And we use the Porter's 5 forces to analyze that. And then using those things, then we will basically get into the analysis of the 4 different industries from where these four companies come. That is Ultratech, Page Industries, Nestle and TCS. Now, we are hoping that while we do this, you get a very good grip on this method of analysis, how this analysis is done. So we will make you then practice this analysis on your own firm. So we will give you a company, each of you a company to analyze, and there is an assignment that you will have to do where you will have to go and write a report on this company using the methods whatever we discussed right in the class. So same method that we have used in the class, similar method you will basically use to do an analysis of your own on this company, and we'll tell you where to go look for data on this company and so on, and you have to write a report, and that will be an assignment. So hopefully with this assignment you get a very good under the first 4 weeks, and this assignment you get a very good understanding of the context within which companies operate, what are the terms that we use typically when we discuss performance of a company, and then how do we analyze the firm's performance using various financial data that the firm provides as well as industry data that is available. Okay, from there we move to case studies. So the first case study that we have for you is called the FabMart case study. It's based in some sense on the Flipkart data set. So clearly it comes from the world of e-commerce. So it's an e-commerce case study. So the guest lecturer that we have over there, Omkar, he will introduce us to the world of e-commerce. What is e-commerce? And then he will tell us a little bit about what this case is about and the data set that we have got in this case. And then Milind and I, we take the data and then we'll work on it. So we'll show you how to work with the data. So we'll take the real data in some sense, and then both of us will take spreadsheets and we will actually work through the data and show you how to do a revenue Pareto, how to do a volume Pareto, how to do a scatter plot, how to do portfolio management, few things like this, right? How to do all these things so that you get a grip on not only understanding the raw data, but also understanding how to process all this raw data to put it together in some charts, in the form of charts, so that we can present it, right? Then in week 6, we will get down into analysis of the sales and organizing the distribution centers that Flipkart has. How do they organize it? In this case, this is a FabMart is the fake case that we have taken. So in the FabMart, they have distribution centers in 3 locations: Hyderabad, Chennai, and Kochi. So how do they organize these distribution centers so that you can efficiently deliver things to customers speedily, right? So it turns out very surprisingly that you can do this by looking at the sales data, okay? And then we will look at some analysis of trends, sales trends. We will look at things like inventory. How do you manage the inventory well? So using this thing called average days of stock out. Stock out basically happens when you don't have material to sell. Customer is looking for something and you don't have that thing to sell. It's called a stock out, which apparently is very, very bad for e-commerce companies. So they keep worrying about having these stock out situations. So how do you avoid this? By using this concept called the ledger. And again here, there will be an assignment for you which will be to prepare sales and inventory analysis for a specific data set. So you will have a data set given to you, picked up from the case study only, and you will have to basically take this data set and you have to do your own sales and inventory analysis report. So hopefully with that, you learn quite a lot about how to look at sales data, how to look at inventory data and make sense out of it. Okay. The second case is for manufacturing company. This is a company which makes gear assemblies. We have called it ACE Gears. It's based on an actual manufacturing company. The data also comes from there, but we have kind of fudged it or massaged it to prevent, to allow confidence, to make sure that the data is kept confidential, right? So that we don't get to know what is secrets of some of the secrets of the company. So we've hidden some things, but still the data is meaningful. It has come from real life. So we've taken this manufacturing data And then the person here, Shiv Kumar, will basically introduce us to the manufacturing sector. He will set the context of the automotive industry, what has been happening in the last 2 years, especially in the time of COVID, this BS4, BS6, there are a lot of technology transformations that are happening. And he will tell you basically that such transformations keep happening in the automotive industry and they have to deal with it. How do we use all the data that is there in terms of sales, production and all that to do planning? Because one of the things that we learned in manufacturing, you have to plan and you have to plan and you have to plan. There's a lot of planning that has to be done. So how do you plan your production schedules? How do you plan your shift schedules? How do you plan your raw material purchases? How do you manage your inventory? All these are huge issues in manufacturing. So we will try and do all that. But before we do that, we will again try and do some revenue trend management and portfolio management using their sales data. And we have, in the case of Mart, we have data for 15 days, whereas in the Ace Gears, we have monthly data. There we have daily data for 15 days. We have monthly data here for 2 years, okay, 24 months. And then we will do some regional sales analysis and try to plan the number of sales agents. We'll do some scheduling. We'll do some analysis of scrap. And then we'll try and do some unit level profitability analysis. So that gives you an idea of the finance side of the world. And how do you do reordering of raw materials using this concept called safety stock, okay? Reorder points and reorder quantities and things like that. Again, here there will be an assignment that will help you to get to your own sense of everything. So we'll give you a data set and we'll ask you to prepare a report on revenue trends, unit level profitability, operational efficiency and things like this using your own data set. The third case comes from the world of HR. So here we have an IT company, it's called Tech Enterprises. It's a fictitious company. It's based, the data is again coming from real world, but we have massaged it and put it into the form of Tech Enterprises. So here we get an introduction to HR as a function. We get an introduction to the data set. So here the basically thing, it's a recruitment problem. So we need to recruit some candidates. So, you know, we have two caselets. The first caselet is about internal sourcing, which means we try to see whether there is a fitment from within the company for a particular position. In the second caselet, we will look at recruiting from outside. Okay, so how do we do this management of this data, recruitment data, candidate profile data? How do we take all of that, put it and then rank the candidates? And so you'll see some examples of unstructured data here compared to the previous cases. So this will be more useful for you to understand how unstructured data can be put together and how you can do ranking of candidates and so on using unstructured data. Finally, the fourth case that we have for you is from the fintech world. This is from our guest who is from PayPal. So the data is also from PayPal, but of course we have massaged it again, and so it's a fictitious case called PayBuddy here. And here there will be an introduction to the finance industry and fintech. We will understand payment processing and how money flows in payment processing, and then we'll introduce a new credit product. And our guest will explain to us basically this whole idea of nudge economics. How customer behavior can be altered or modified by using this method called nudge, right? So by giving default options and things like that. So we will learn that. It's quite interesting to learn. And basically using nudge economics, a new product, credit product, basically we want to introduce. So we want to see how well that credit product is doing. And for that we use what is a method which is called A/B testing. So how does the A/B testing work and how do we analyze the A/B testing data? And finally, there is this is a credit product, so you have to evaluate credit risk. So how is credit risk actually evaluated by forms like this, and how do we do risk return trade-offs? These are things that we will do. Again, there will be an assignment which will help you practice everything in terms of you will have to write a report where you have to come up with your own recommendation rules, do some A/B testing analysis and so on. So you will get to learn how to do all these things yourself. Okay. Finally, the course project. Okay. We expect every one of you to do a project where you will have to identify a small scale enterprise in your neighborhood. If you have difficulty with identifying a small scale enterprise or whatever it is, then we can help you with either identifying or getting this data sourced for you. So one way or the other, we will make sure that you get your hands on some data that you can work on. So this will be your own data, unlike all the other assignments and so on, which is packaged data, already processed data in some sense, cleaned and all that. Here it will be unclean, there will be all kinds of issues, there will be noise. You have to deal with it yourself, okay? So talk to your neighborhood kirana store, vegetable vendor, textile store, furniture store, electronic store, workshop, whoever it is, restaurant, tea shop, barber, beauty salon, doctor, diagnostic clinic, anybody who is doing something which is business, okay? And we expect you to collect some business data from this firm and over a period, and then prepare an analysis report. We'll tell you how to do it, and use all the techniques that we learn in this course while you prepare this report, and then you will present this as a thing which has a significant weightage. Okay, and we will have people who will help you with it. So we have tutors. We are having a large number of tutors who are going to be assigned for this course, who will basically help you with preparing, looking at this data, preparing the report, and so on. Okay, so the last week, which is week 12, so up to 11th week we'll be doing case studies. Week 12 we want to use basically mainly for you to work on your project work, course project work, and we will also be presenting the learnings from the case studies that we have gone through in the course. So this is basically how our 12 weeks course is going to run. I hope you all enjoy this course just as much as we enjoyed putting all this material together and delivering it to you. So in case you face any problems while going through the material, feel free to write to us, and then we will be as responsive as possible to give you clarifications and help you to get along with this.
So that was a comprehensive video on the business data management course orientation. So today we have a few instructors, and there are a couple more who are not joining today. So perhaps they'll be joining in the upcoming live sessions. Today we have Sukrat and Jaimini with us. So Sukrat, Jaimini, do you want to add some more to this course orientation?
Sure, thanks, Aisaj. It's actually, I'll just turn my camera on. So the best you can expect out of this course is that it'll be an intro to a lot of real world problems, and although the scale of the data won't be as huge as it is right now in the world out there, but just to practice and to start with, to understand how all the stuff is dealt with on a very basic ground level, to get a deep understanding of it is definitely something that you should expect if you are enrolling for BDM. I'm a course instructor for BDM right now, and the assignments that exist, like the way they are structured, are to give you a rough sense of how you will be doing it on a greater scale eventually.
All right. Sukrat,
we
we
will
are
try to respond. Yes, sir.
Yeah. Sure. I think we are running short of time. So
All right.
What we can do is we'll move on to the questions quickly. So I'll focus on few important questions.
Yeah.
So the first question: how much time should a student spend on this business data management course on a weekly basis? So what do you think? Is it around 4 to 5 hours a week? Will that be enough? Jaimini, you can also answer this question.
I think apart from watching the videos and your homeworks, you can per week you can contribute around 5 to 6 hours.
Okay. So the
Yeah,
next
because
question is.
yeah.
Sorry, Jaimini. Would
Yeah,
you?
and you also need to focus on the capstone project. So
Yes.
there you will need some time, because you have to first identify a problem. You have to go to the concerned stakeholder from where you will collect data, and what data you will have, and what kind of analysis you will be having. So for that also you will need an additional 1 or 2 hours a week.
Yes, very true. The next question is this a theoretical course?
Definitely no.
So it's a mix of
Yes.
both theory and
Yeah.
hands-on. Especially the first 4 weeks will focus on the theoretical part, but after that it's going to be real-time case studies, and you're going to be working on real-time industry data and so on.
Yeah.
And next question is a little funny. Are BDM and tools for data science the easiest in diploma level? Definitely no.
Definitely no.
To an extent, business data management could be
Easy.
relatively easy, but definitely tools for data science is not at all an easy course. We have Dixon with us. Soon he is going to give you an overview of tools for data science. You will understand the level of tools for data science in very shortly. All right. Apart from that, so after this business data management course, can I take business analytics? The
Yes.
answer is yes. In fact,
Yes.
business data management is a prerequisite for the business analytics course. So the next question is a little interesting. After this course, will I be able to read the financial statements of companies?
Yes, somehow you'll be able to do, because for first 4 weeks, they'll be talking about the financial health of a company. So you'll have some theoretical background also. You can see, you'll be taught how to see the balance sheet. So definitely you'll be having an overview how to look into the statements.
All right. So that's all the questions we have for business data management course. So we'll quickly move on to business analytics course. So this course will, for the orientation, we'll start with a video by Professor Rahul and Mr. Anand Srinivasan. So this is going to be a joint conversation between Professor Rahul and Mr. Anand. So after these videos, we'll try to answer a couple of questions posted by students on the forum. So let me share my screen, and Gemini, please tell me if the audio is visible.
Sure.
And audio on the video are.
Yeah, it is loading.
Well, let us start this session on introduction to.
You can increase the volume. You can increase the volume.
Sure.
Yeah.
Well, let us start this session
Yeah,
on.
it's perfect. Perfect. Now we have lost the audio again.
Sorry, Gemini, did you say something?
Just now we lost the audio.
Okay, so let me try again. Srinivasan with us today, joining in.
Yeah, it's running. It's perfect.
Okay.
Anand is an IITM alumnus, BTech 1995. Is that correct, Anand? 1995?
Yes,
1995. Yes. And he has been very amazing data scientist throughout his 26, 27-year-old career. Has worked with multiple industries, airline industry, Sabre Technologies, Dell. He was with the senior management at GoAir. And now he is about to start a new venture, a new airline, which is going to be launched very soon. I can say that formally, right, Anand?
Yes, you can say that formally, Rahul.
Perfect. So very glad. Anand not recently actually, Anand was listed as the top 10 data scientist in India. So very lucky to have you, Anand, joining us today for the session. So welcome, Anand. And today we want to understand your views on what is business analytics.
Okay, so the whole concept of what you consider business analytics, right? I mean, look, it's at this point, even business analytics is old school, right? You have to talk about data. That's a new age. Look, it's nothing new. It's been around since before I started my career. People are doing this, and we will continue to do this, right? Fundamentally, how do you improve a business function, right? By end of the day, you're making decisions. How do you support all the decision making by facts rather than speculation? Plain and simple. And at the core of it, you peel all the layers of the onion. That is what is left, correct? And analytics as a function is supposed to actually look at data, correct, and provide that ability to make decisions basis right data, correct? Now, what started off as a simple promise, right, has grown into this 800-pound gorilla called data science, and now even data science is not acceptable, right? It has to be AI/ML, and then so if you look at it, there's a even a whole bunch of names that go around, right? Somebody says like, who wants to be a data scientist? Everybody puts up their hand. He said, who wants to be a statistician? Like nobody puts up their hand.
Yeah.
Right?
Yeah.
So look, honestly speaking, I am not going to decry the value. I think it's probably the single most powerful business tool a business can have. Right? We always talk about being driven by analytics. Now, tech plays a big part into it because the availability of data is powered by tech. Correct?
Yes.
If you don't have the right systems, then if you're doing stuff using paper and pen, right, you can't have too much analytics. Correct? Because and then you have techniques that keep coming up, right? I mean, like, look, let's face it. We're all OR practitioners. We learned about fundamental LP, IP, mixed integer programming, dynamic programming, all that stuff. Now, the same concepts apply, right? But then you also have a whole bunch of statistics. Understand. Can we look at large volumes of data? Understand whether there is a significant deviation from a test and a control group. All the usual stuff which we teach the fundamentals. The problem is in the course we talk about the fundamentals, right? And it goes into the business world, right? It gets metamorphosed into a different animal altogether.
Yes.
And unfortunately, people from the business side do not really understand what core techniques are there. I mean, it's one of those like, why are you boring me with statistics? Listen, you want analytics, it is at the core of it is statistics. Correct?
Yes.
So this whole concept of analytics, if you ask me, it's not overblown, it's overhyped from a data science perspective, right? The value is unmistakable. Correct? It's about how you do it that becomes a problem, right? And again, I build this model and I build that model, etc. I mean, it's about the decision making, right? In fact, I used to don't talk about data scientists, talk about decision scientists, because at the end of the day, what people need are good decisions. And anything that can help you make a better decision is a useful thing to have. Anything that doesn't help you is not worth having. Correct? And then you keep hearing about machine learning, deep learning. I mean, conceptually is nothing different from what you used to talk about neural nets that have been around for a long time. Correct? And what you have supervised learning, unsupervised learning, a whole bunch of things. What we used to caution people against, overfitting models, now become learning models. Correct?
Yes.
So the problem is in an effort to democratize this analytics, correct? I think the industry is kind of dumping it down. So, which to me is a bit of a more dangerous situation, right? So, look, let's face it, right? Businesses realize that the value of doing good analytical model-driven decision making is phenomenally useful. So, there's a bit of a gold rush to go after and say, look, we need to empower our people with this. And obviously, people are looking to bring people on board with this kind of skills, and it takes time to get. Demand is way it exceeds supply by an order of magnitude. Correct? What comes then is a bunch of systems tools that claim, I cringe whenever I hear the word called citizen data scientist. Right? A citizen data scientist to me is the equivalent of the Tweeple or Twitterati, right? I have a Twitter account. I have an opinion on how Obama should run his foreign policy and how Joe Biden is not, a good president for the United States of America. I'm not a citizen. I just have a Twitter account and I can say whatever I want. Correct?
Yes.
So to me, the whole concept of a citizen data scientist, I think, runs the risk of that. Correct?
Okay.
Would you, simply put, right? If you have a medical condition, right? Would you go to a doctor to get it checked and have a prescription, or would you say put a poll on Twitter and come back and say, "Let me take the drug that all the Twitterati are recommending"? Correct? You don't. Right? Same way. Would you go back and say, if you're a CEO and I need critical decisions to be taken, correct? Am I going to go back and bring somebody who studied the field, or do I go back and say, I've got somebody who's just taken up a tool, thrown data into it, and whatever it spit out, I'll come back and say, look, I'm going to go with this.
Yeah.
Right? So to me, I think we run the risk, right, where tools that were built to make the process of analytics easier for practitioners have become the gospel truth.
Yeah.
Where they're saying, oh, it's like saying, have you seen this, right? You don't need to have no statistics to become a data scientist. I've seen it advertised. Do you want to be a data scientist? You don't need to know statistics. You don't need to know computer science.
Wow.
So what do I need to know? Cooking? Right? So to me, I think, and I think that's where we run the risk, right, as an industry, is to come back and kind of, in an effort to make the process of data science or make the life for a data scientist easier, correct? And to meet the need of the industry hunger for data scientists, correct? We just lower the bar and say, you know what, anybody can be a data scientist. Right? Again, generational thing. I remember back when I was a teenager, you had a TV on show on, I think it was MTV, right? It was called Yang Can Cook. I mean, it's a cooking show, right? And there's a chef called Yang, and he would actually walk people through how to cook various dishes. And his catchphrase was, "Yang can cook, and so can you." Right? I'm sorry, which is, and I absolutely agree, right? Yang can cook, so can I. As far as I'm making a meal for me to sit and enjoy with my friends and family.
Yes.
Am I going to build a restaurant around my capabilities of having learned how to cook a dish from a TV show? The answer is no. Right?
Yes.
And I think that's where the problem is when you go back into analytics and AI, ML and things like that. What's happening is there is way too much supply or way too much demand chasing not enough supply.
Okay. But that in general, the applications of data science in general are going to grow, and therefore we are going to need more people trained in data science, right?
Yes, absolutely. Yes. Only thing is, we will no longer be training data scientists, we will be training AI ML engineers.
And you make the differentiation that AI ML engineer is not a data scientist.
No, that just draws a higher pay package on your resume. Right? So, look, I kid you not, right? I have had instances when I've been talking to some businesses and they will say, look, Anand, we have this problem. My approach is, let's talk about the problem and then let's figure out how to solve the problem. And then when I spoke about it, they said, no, but I want to use it using a big data approach. Right? No, can we use, so the thing, or the other thing, can we use some AI to do this? Correct?
Mm-hmm.
Without really understanding what it is, right? There are certain things that the field of AI, more than ML, AI and it's a very different field, right? I mean, when you talk about what computer vision can do and things like that, that's a completely different arena as opposed to what ML is. So I think, first off, this whole concept of AI/ML is, I think, misleading. AI is a very, very different focus. Machine learning is a very different focus. Correct?
Yes.
Now, AI is useful on things that we don't have solutions for. Correct?
Yes.
The way computer vision is going, right? It's just mind-blowing, mind-boggling in terms of the capabilities that come. And when you leverage that advances with other things, then stuff that was unheard of is possible now, right?
Yes.
Where computer vision is going, right? We are talking about people talking about inventory stocking at a warehouse using drones that are capturing video on the fly, and using computer vision is actually counting how much inventory you have. Correct? I've heard cases where you're using drones to identify defects on solar panels or on a solar farm. So can you imagine this? You have a huge solar farm and instead of going individually inspecting every panel, you fly a drone over that and it captures video. It actually identifies defects.
Wow.
Right? So to me, these are all advances this is AI kind of talking about it, right? But clubbing AI and ML, I think, does a disservice to the strengths of both the areas. Correct?
Okay.
So I think people just need to be a little calm, right, and then understand that what you call it, and the beauty is over my career, right? I have seen being called from a business analyst to a data scientist to a AI ML practitioner to a big data expert. I've been called multiple things. only these I can reveal in a public forum. The other things that I've been called is for a private conversation, right? But bottom line is that, right? I mean, I'm talking over a short span of my career. When my day to day, when I go to work, office, the work I was doing was the same, right?
Yeah.
But my business card and my designation and what people call me kept changing, correct? So it's just the same thing, business, and it's nothing major. Just as with any field, you're going to have newer development, newer technologies, and newer models, and people are going to try to figure out how to solve those using that.
Okay.
Right?
Okay. Coming back to the more precise term, business analytics, right? I have always understood that as essentially three components: the business problem, the mathematics and statistics, and the computer science. Essentially, those three have to interact.
Right. Absolutely. I could have explained it better myself. It's basically a confluence of these three, correct? And the problem is you have a business problem, right? I have the element of the supporting data infrastructure for that to what you add. Okay, so whether you house it under the computer science or the mathematical model is up, because what will happen is business comes with a problem, right? I go back and say, okay, I can model this way, I can build this way, but then what data do I have to work with? Right? So I will build a model that can consume the data at the level of granularity and detail that is available to me today. Right?
Yes.
And I solve the problem and I give a solution. Now I'll come back and say, I'm now assuming that you have slightly more granular data. I might be able to build a better model.
Okay.
That goes back to the infrastructure to say, okay, now can we start collecting more data? Now, this cycle keeps going on and on, right? So in fact, I always talk about, when I talk about a model, we'll start with what I call a low-res model, a low-resolution model. And as we get better data, we can build a high-resolution model, right? And in fact, I think that's where another thing, right? So for instance, if I say, look, I only have data, which is monthly data, sales, and I build a model that forecasts monthly data. Don't try to extend the model and say, I'll forecast how much sales you will have on next Saturday. Correct?
Yes.
So your precision of your model cannot exceed the precision of, there is fundamentally, no model can increase the precision of the output to be higher than the precision of the input.
Correct. Yeah.
Right? I think, if you had to inculcate one concept into every student that goes to your class, I would say, inculcate this into them so that eventually when they go on to become executives, they don't make unreasonable demands of their data set.
Yes.
Right? There is no model today, correct, that can give you an output whose precision exceeds the precision of your input data.
Exactly. Can't. That is unrealistic expectation. Yes.
Right? So, what you're doing is doing some interpolation speculative methods in between.
Yes.
Correct? And but that's a core thing. And those actually, lead compound errors. Correct? So to me, the correct way to solve the problem is you go back and fix the data infrastructure and say, look, let's collect more data.
Okay.
Now, what has happened over time is with the way storage is getting cheaper and tech is going with IoT and all that, what the tech guys got tired of listening was, can you collect more detailed data? Can you give me more detailed data? They just said, look, I'm going to collect everything and throw it in there. Do what you want.
Exactly. Yeah.
So hence we have created this thing called a data lake. From where we had a data warehouse. Okay. Let's understand what literally the English connotations of the terminology, right? A warehouse is where you store something in an organized way. A lake is where you throw something in completely without bothering to organize it. Correct? So what they've said is, we have given up trying to organize the data in a structured way. I'm just going to dump it here, do what you will. Correct? So, but and again, the cycle will come, right? Basically, now that we have this, you will start getting more sophisticated models, which will be able to answer more nuanced questions, which will in turn demand more granular data. So the cycle will keep going through. We are at a point where, when I was a grad student and when you were probably a grad student and things like that, right? You are trying to build models and you say, look, I can't do this because this is the extent of the data that is available.
Yes.
Correct? Hence, we can't build a more granular model. Correct?
Yes.
Then the data started getting available. Then you ran into computing power.
Yes.
Right? So now the computing power. So essentially, it's the same thing, right? Mathematically, you have a constraint optimization problem, and one by one, the constraints are getting removed. So what happens is when one constraint gets removed, something else is going to become a constraint.
Yes.
Is going to be a binding constraint.
Yes.
When you remove that, something else is going to become the binding constraint.
Yes.
So essentially, we are going through a journey of different binding constraints are being removed. Correct? Only for something else to become a binding constraint.
Yes.
Correct?
Yes.
So that way, today the availability of data is not a problem. Correct? Right? But the classifying the data, putting it in a structure becomes a problem.
Okay.
Assuring the quality of the data is becoming a problem. So people are working on that. Correct? Now, when you look at that, right, somebody will say, hey, well, you know what? How do you do an audit? Right? So you are actually building AI, right, to actually audit the quality of the data so that can be used for, so you kind of got machines talking to machines kind of thing happening.
Yes, yes,
right?
yes.
So it's just a question of, at one point we said no data. Then they said, look, I'll get you the data. Then we said, oh, we don't have computing power. Then we got the computing power. So which allowed us to build more nuanced, more sophisticated models from a stats modeling perspective. Then we got into a point where we have too much data. Now we can't trust the quality of the data. Now we are building stuff that will address the quality of the data.
Yes.
And that process, you are creating completely new capabilities.
New
capabilities. So it's not going to end. Correct?
Yeah.
Hopefully not. Right? So it is going to keep going on. What is going to happen is different elements are going to get hyped up at different points of time.
Okay. Yeah. Correct.
But analytics as a whole looks at all these three. Absolutely, yes.
Correct. So just to talk about the course outline for this business analytics course that we are going to run through, we are going to have a session on visualization, which is going to be the first session. Then we are going to talk about posterior probabilities. We are going to talk about regression. We are going to talk about consumer choice models, particularly conjoint analysis. We are going to talk about efficiency and productivity through a optimization model called data envelopment analysis. Those are the kind of topics that we are going to see. The emphasis is not going to be on the technique per se, because I'm hoping that is done in other courses. But the emphasis is going to be on taking a business example and solving it in using one of the methods that I have described. So that's the way the course is going to be run. There is going to be tutorial sessions on some platform, Python, R, Excel, one of the things we will pick up and have tutorials. And there are going to be explanation sessions run by TAs. So that's how the BA course is going to run.
Look, yeah, so I like the approach of let's take a problem and then pick a technique that is appropriate to solve the problem, and then walk people through that, rather than saying, let me teach you co-joint analysis, let me teach you regression, and let me teach you dynamic programming. So, I always talk about, people come to the table armed with solutions looking for a problem, right? So I think that's where the biggest challenge, Rahul, from my experience, is not people knowing these techniques. Is actually choosing the right technique for the right problem.
Exactly. Yes.
In fact, remember I was talking about once the message is clear, the form becomes evident.
Yes.
Right?
Yes.
Once you say, hey, for this kind of a problem, this is the kind of technique or technique I should use. After that, solving the problem and putting it together becomes almost a trivial exercise.
Yes.
Now, I would say a significant portion of business analyst data time is spent or lost because they are chasing a completely wrong technique to solve the problem.
Yeah.
Right? So anything that addresses that and teaches that, I think is going to be valuable. right? And you know how modeling people are, right? Eh, any available heavy object becomes a hammer, right? So which means that so I've known people who have done a lot. I mean, I'm guilty as charged myself, right? There are times when I look at it and say, you know what, this can be solved using a mixed integer programming problem, right? Because I'm very comfortable with that technique. It's easy to go back and say, yeah, let me formulate this as a generalized assignment problem and stick it in there. Is that the best way to solve it? I don't know. Correct? So sometimes having that broad-based knowledge of techniques and allowing us the ability to choose the best technique for the right kind of problem is, in my opinion, much more critical than knowing 20 different techniques.
Yes.
Because if you know 2 techniques, you can always pick up the third.
Yes.
Right?
Yes.
So to me, I think emphasizing that is actually much better. Let's say, here is my course on business analytics. Let's just talk about numerical data and ordinal data and cardinal data and regression and logistic regression, and then 1, 2, 3, 4, 5. People are just coming out saying, okay, look, I know all this. So it's like saying, sitting there and learning all the different types of conjugations of verbs in French. But then I land up in Paris. I don't know how to ask them how to use a washroom. I have to find the washroom, right? So focus that rather than I don't need to know the details of French. I don't need to know how to do passé composé and this and that and what have you, right? But at least can I have a conversational French, right? With the depth coming in later.
Correct.
Not to belittle the depth that comes in. The depth does have a huge bearing, but then you will find 2 types of, as with everything, 2 types of analytic solutions. One which is the broad-based ones where you can look at a problem, do some quick top-level analysis, come back with predictions, and there'll be some where you'll say, look, there are some problems that I need to throw into an expert. Let me throw it to an expert and let them work on it.
Correct. So I think the idea is to be true to the problem that we are going to solve rather than the technique that we might be biased towards, right?
Yes, absolutely. And all of us, whether you like it or not, have biases.
Yes. Correct. So hopefully this course focuses on how to solve a business problem rather than teach you techniques which you would have anyway picked up from other courses. Let's hope that we are true to that objective.
Okay,
so once again, with that, let us close this small session. So once again, thank you, Anand. Thank you for sparing your time and being here with us to record this. Thank you.
Always, Rahul, glad to help anytime, and I'm hoping the students benefit from this course. Sounds very exciting. I'll be very keen to see how it progresses.
Sure. Thank you. Thank you.
Bye.
Bye.
Oh, fine. So I hope you enjoyed the conversation between Professor Rahul and Mr. Anand. So before that, we have the tools for data science folks here. So I would like to take your permission. I want to take another 10 minutes to discuss few things about business analytics. We started 15 minutes late, more than 15 minutes. We had some technical problem. Therefore, we need 5 more minutes of time. So this was a general discussion on business analytics course. Coming to the contents of the course will start with visualization, and then it will move on to some statistical techniques like fitting distributions and chi-square tests. Then we'll get into predictive models like regression, logistic regression, and so on. And then we'll move on to prescriptive techniques like data envelopment analysis, conjoint analysis, and so on. So again, the emphasis is not going to be on coding. So we'll be providing you with data sets and codes. The challenge is on interpreting the results you get out of the coding part. So we will not test you on the coding front. We'll be testing you on the interpretation of results. So with that, we'll look at few questions posted by students on the forum. So does business analytics require knowledge in statistics? So Jaimini Srivatsa, would you like to answer this question?
Srivatsa, can you please?
Yes, Jamie.
Yeah.
So it does require you a basic knowledge in statistics. I think that is covered in some of the foundational courses. That should be sufficient to take up this course, is what I suppose. So you can go ahead with this course if you have a basic knowledge of statistics.
All right. The next question is BDM a prerequisite for BA? The answer is yes.
Yes.
And the next question, Jaimini, can you answer this? How heavy is business analytics?
Yes, compared to BDM, this thing here, BA course will be heavier in terms of computation, but the only thing, you no need to code. We will provide you all the Python code or anything required, but you have to do all those things on Excel. And main thing is that you have to interpret the results. So in BDM, we'll be mostly looking into, say, in the business perspective of the data, but in BA, you will have hands-on. Like you have to solve. Yeah.
So next question is, I found BDM to be fairly easy. How is BA different from BDM?
Some you can answer that.
So BA, the focus was mainly on the visualization front, understanding the business cases and so on. BDM is, that was BDM. In BDM, you focused on visualization techniques and a few case studies. BA is going to be slightly challenging in because you have a lot of statistical concepts. You also have some optimization concepts. There is also coding part involved. Therefore, it is going to be slightly difficult compared to BDM. The next question is, so before the start of business analytics course, how can I prepare myself?
You can brush up your the statistical techniques you have learned already in the previous courses. That will be very helpful. And
Yes.
also you can have some, if you are new to Excel, then you should get familiar with the functions, preliminary functions. But anyway, those things we also will teach you through tutorials, but you can get yourself acquainted with Excel if possible. It will take you, say, 3 or 4 days practice.
All right. With that, we wrap up this BA orientation session, and then we hand over it to Tools for Data Science people. I wish the very best for all the students who are crediting business analytics course. See you soon in another session.
Good evening, all. So I think let's start our discussion about TDS. Narayanan, can we please play the video?
It is not audible. Still not audible.
I think the sound is not shared, only the screen is shared.
Yeah.
Sorry?
Your voice is not coming. Only the video is getting played.
Yeah, I think you have to share with audio. We are only able to see the screen, the video, not the audio.
Welcome to the course on Tools in Data Science. This course
perfect.
is part of the Diploma in Data Science that's offered by IIT Madras. The courses in the Diploma for Data Science, they cover the theory and applications of data science techniques. In this course, we'll teach you how to actually implement the techniques that you've learned in the other courses. Now, techniques are more important than tools. Tools have a relatively short shelf life. Techniques last much longer. But without tools, Diploma in Data Science, you can't implement anything. And you need to understand what tools are used in the industry today in practice for you to be able to apply what you've learned. And therefore, while the other courses are important for your learning and your long-term career, this course is necessary for you to succeed in your current and your next job. Welcome to the course. Some interesting things you'll do in this course are create clusters and visualize them, explore 3D maps just in Excel, animate bar charts in Flourish, create network diagrams using Kumu, and even create comic data stories with ComicGen. To introduce myself, I'm Anand. I am an alumnus of IIT Madras. I passed out in 1996 in chemical engineering, which was a mistake, by the way. I had selected every option when I joined, with the sole exception of chemical engineering. But the professor who was counseling me said, no, for your rank, you'll get chemical engineering. So just put a check against that, and he pretty much did it for me. So I spent a few decades trying to correct that mistake. And it was only 10 years ago that I found my calling, my passion, which was data science. I, along with some of my ex-colleagues, founded a company called Gramno. We are a data science company. And what I've been doing over the last 10 years is helping people understand data better. And this is specifically by taking data and plugging it through what we deem as insights rather than just analysis. An insight needs to be something that is big, useful, and surprising. There's no point telling something they already know. It's got to be surprising. You don't want to go tell an umbrella salesman that one of the biggest factors that will influence your sales is rain. He knows that. It's also got to be useful. An umbrella salesman can't influence the rain, but it might be useful in some other contexts. If you told a farmer that you need more rainfall for your crops to grow, that can't help him. But if you were to tell a large company like Monsanto, who could do cloud seeding, then yes, you can actually influence rainfall. So usefulness is contextual, but usefulness is important. And it's got to be big. There's no point having a 0.1% improvement in the bottom line. So that really doesn't work. Whatever insight we deliver has got to be big. And it's got to be narrated as stories. Stories are memorable. Stories are viral. That's what enables action. And that's what I've been doing over the last 10 years. Over these 10 years, I've been using a wide variety of tools and found that some tools capture the common patterns with which we do data science, with which we help people understand data much better than others. And in this course, what we'll be doing is sharing those best practices, but taking you through step by step how each of those could be applied to something that will hopefully give you insights from data. So what should you expect in this course? What should you not expect in this course? Well, since this is a course on tools, not techniques, it's very hands-on. We'll show you how you can get the results that you need and how you should be able to interpret them. But you won't really learn any of the theory behind it. You won't learn why it works or how it works, at least not in this course. Similarly, your evaluation will also be based on how well you understand the tools and not the theory behind it. Let me give you an example. Let's say we're talking about clustering. In this course, you'll learn how you can create a cluster. We'll be talking you through how to do that, for example, using the Python library scikit-learn. But we won't, in this course, explain what k-means clustering is or how the algorithm works. The focus, both of the content and of the evaluation, is on application, how you use tools and libraries, rather than why it works or how it works. Let's look at how this course is going to be taught and how it's going to be evaluated. This course has 8 modules, and we'll be covering these 8 modules over the course of 12 weeks. Every module will have a set of videos that you can learn from. These videos will take you through real-life data sets and show you how you can apply the tools hands-on on those data sets. Second, you will also get reference material, and these are typically links to the code or working samples or output along with the data sets, and you can use that to compare your results against. Third, after each of these modules, you will have a weekly quiz that you can take on the board. I strongly encourage you to follow along these videos by doing what the author is showing you. That way, you will, number one, get a guided tool. Second, your familiarity with the tool will grow, and that's really the most important thing. But also, there is the opportunity for you to explore and tweak the analysis. Some of these data sets are really interesting data sets, and you might find something that is new, something that's interesting. And with that, perhaps even grow your interest in data science by doing rather than just learning. In this course, we'll be going through 8 modules. These modules take you through the typical journey a data scientist goes through to start from understanding the problem to getting the data to finally solving the problem and sharing it with others. Specifically, the first module is around discovering the problem. The second is about getting the data. The third is preparing this data. The fourth is modeling this data. The fifth module is on modern tools that can simplify deep learning. The sixth is on designing your output. The seventh is on narrating as a story. And the eighth is in deploying your results. I'm going to walk you through what you will learn in each of these. The first is on discovering the problem. One of the most important things that as a data scientist you need to do is figure out what problem you're solving. And while often problems are given to you, there are systematic approaches and simple tools that you can use to make sure that, number one, you know who your audience is. Number two, you know what the specific problem is that they're trying to solve. And third, what the impact of solving that problem is. And this will come in really handy in making sure that you're solving the right problem for the right person and that you're solving a problem that is really worth solving. The second module is about getting the data. And this is critical because without the data, you will not be able to do anything. And often data is not handed to you in a clean and easily extractable form. You will have to go out there and extract it. There are many ways of doing this. Sometimes there are libraries to be able to pull the data from a particular source. For example, if you're looking at geospatial data, then geocoding APIs are easily available. If you want to pull some data from Wikipedia, which is an excellent and rich source of data, then there is a Wikimedia library that is available. You may also be able to get data through scraping. If there is a website that has data, then you may be able to get the data from that website by using libraries that can pull the data off of these sites. The data could be potentially in PDF files as well, in which case you will need the equivalent of a PDF scraper. And what we'll do in this module is talk about the tools that can simplify this job, as well as the underlying libraries that will help you write the scrapers, the APIs, and tools that can download from multiple sources. The third module is about how to prepare the data. And this is important because if you don't have the data set up in a form that you can analyze, then it's meaningless. Typically, the first thing that you'd want to do is load and take a quick look at the data, sort it, explore what the columns are, and so on. The second thing that you'll want to do is transform it in a way that you like. Maybe create pivot tables in Excel, maybe create derived metrics out of it, add up some columns. Thirdly, one of the most difficult things that you may end up needing to do is to clean up the data. There could be missing data, there could be wrong data. You want to identify where these problems are and at the very least flag them off, if possible, avoid them, and better yet, be able to fix them. In the fourth module, we'll be looking at how to model the data. Modeling the data is about doing the analysis, where you put together a system that takes the data as input and starts giving you meaningful results. We'll start by modeling data using simple statistical analysis and then go on to basic machine learning techniques. Some of the things that we'll be covering the tools for will include regressions, correlations, outlier detections, how to classify data into various categories, how can you do forecasting, how can you do clustering, and so on. In module 5, we look at some of the modern tools that simplify deep learning. This includes techniques like text analysis, specifically sentiment analysis and classification. Text classification in particular is a hot area for which some of the tools that exist today are really powerful. We'll also talk about how we can, in simple ways, classify images. And finally, we'll look at some more unconventional methods of analysis, such as network analysis in the context of social network analysis. And we'll be looking at geospatial analysis. But we'll be doing these through tools that you are familiar with and potentially are very accessible to you. In module 6, we'll go to how you can design your output. How can you create simple depictions of numbers that help you understand your output? What are the tools that will help you create charts, especially charts that are somewhat beyond the conventional norm? In other words, charts that convey exactly what you want to convey rather than what's easily available. We'll be exploring several kinds of specialized visualizations. Word clouds, for example, animated charts like the bar chart race. We will be looking at custom spatial layouts that are often used in digital twins. We'll be looking at network visualizations. We'll be looking at geospatial visualizations. And in all, we will be covering a gamut of visualization tools that can go beyond what standard charting techniques are available in the vast majority of the modules. In module 7, we'll talk about narrating a story. This is critical because the vast majority of the analysis stops short of communicating a meaning, communicating an intent. And what you really want to do to create influence is to put all of this together in the form of a meaningful story that tells the audience to do something. There should be a moral of the story ultimately, and that's what this section talks about. But the thing about analysis is that you don't necessarily know what the output is going to be, and you end up crafting that manually at the end. What we'll be covering here are tools that can actually create the narrative automatically. Specifically, just like you can use data to generate charts, you can use data to generate text, and the output will effectively automatically narrate itself. And we'll be looking at the tools that you can use to create that. And stories don't necessarily need to be narrated only with text. In fact, we will be looking at how you can use comics to augment and create more engaging stories. Finally, in module 8, we'll be talking about how you can deploy the results of your applications. So if you built an application that gets the data, let's say scrapes it from somewhere and cleans it, models it, renders it as a visual design and narrates it, how do you go about putting it out there for people to use? What are the kinds of libraries that you can use to build web applications? What are the kinds of services that you can use to host these? And how do you package these together? These are the kinds of things that we'll be covering in module 8. In all, these 8 modules are intended to take you through the typical sequence that a data scientist goes through for a single problem, right from finding the problem to having the audience get the answer by deploying it. But none of this is purely linear. There will be several iterations through the process. Sometimes you may have to rediscover the problem after you've solved it. Sometimes you may have to remodel it. Sometimes you may have to redesign it. Sometimes you have to re-narrate it. And it's a very iterative process. But here, the most important thing is the speed of iteration. And what tools help you do is accelerate that speed of iteration. So in the course of us exposing you to a wide variety of tools, hopefully you will find those that can make your workflow much easier, and therefore the speed and the cost of doing it are dramatically changed from before. What are the tools that we picked for this course? Well, we looked at 3 things when choosing the tools. 1, the tool should be popular. 2nd, it should be long-lived. And 3rd, it should be general purpose. That is, it should solve our needs for as many, in fact, if possible, all of the modules that we are looking at. The first 2 are good criteria. Popular because then you'll have enough support material and a community around it. Long-lived, it's proven the test of time, enough people find it useful. So that is something that we can rely on. General purpose is a good idea because you can learn one tool and use it in many areas. But the reality is that no one tool solves all problems, and quite often we need the best in class. So we made a trade-off. What we did was we evaluated dozens of tools and we consolidated the technologies into, firstly, the smallest subset that gives you the most bang for the buck. And then we added the technologies that are best in class in each of these areas. So what are the tools that have the smallest footprint and give you the most bang for the buck? Short answer, Python and Excel. Why? Firstly, they're both very popular. Python is one of the largest programming languages that is out there in use, and within the data science community, it is the largest programming language in use. Why Excel? Because when it comes to data processing, it is the single most popular tool in the world and outstrips Python by an order of magnitude. It's also something that you'll find deployed on the machines of practically anyone who deals with data of any kind, even if they don't even know that they're dealing with data. They're both long-lived. Both of them have been around since the 90s, and as a concept, spreadsheets have been around since even longer, and the basics of Python as a scripting language has been around for even longer. So these are very well-tested, very robust, and it's not just that they have a good base of libraries and support around them, but both of them have also gone through the iterations of best practices that are captured into the core product itself. Thirdly, they're both general purpose. Both can be used in every step of the data science process. Specialized tools like, say, R. R is really good at modeling. Tableau is really good at data visualization. And we will be covering these tools in the respective modules. But Python and Excel work in every step of the way. For example, Python is an easy choice in this regard. It's got a wide ecosystem library that is excellent at sourcing and scraping data from any source. For example, libraries like Scrapy do that really well. It does a great job of data transformation with libraries like Pandas. It does a great job of machine learning with libraries like Scikit-learn, Matplotlib, Bokeh, Plotly, these Seaborn. These are great libraries for data visualization and deployment through libraries like Streamlit, Flask. That becomes very easy and powerful as well. Excel too has a really powerful base of capabilities in terms of sourcing data, including scraping from the web. Excel has some fairly robust capabilities. So the thing about Excel is that not everyone necessarily knows what you can do with it. You'd be surprised that you can do 3D geospatial analysis in Excel out of box without even any add-ins. And you can do machine learning specifically. You can do sentiment analysis in Excel directly. It's a very versatile and, more importantly, an evolving tool. But the thing that Excel has going most for it is that it's the easiest of the tools to learn. So what we'll be doing is covering both Excel and Python in every single module and telling you how you can apply the tools of data science through Python and Excel for any task. But that apart, we will also be looking at best-in-class data tools. See, many of the things that you're learning in data science are relatively new, and specifically the material that you'll be learning in other courses, they may not necessarily have out-of-box libraries, and even if they do, they may not stand the test of time. But it is useful to know about some of these specialized tools, know what they can do, know how to use them, and constantly need to keep your eyes open for newer and better applications that can do the same job. So we will be covering tools like, for example, in the first module, getting the data, we'll be talking about Tabula to get data from PDFs. We'll be using a web scraper extension for Google Chrome. In the module Prepare the Data, we'll be looking at Trifacta and Airflow as a way of transforming data. We'll be looking at Open Refine to clean data. When it comes to modeling, we will be covering R and RStudio. We'll be covering QGIS for geospatial analysis. When it comes to designing the output, we'll be looking at Tableau. We'll be looking at tools for specialized visualizations like Kumu for network graphs. And when it comes to narrating a story, we'll be looking at tools like Quill for Tableau or Smart Narratives for Power BI, or how you can use ComicGen to generate comic stories. When we will be deploying applications, we'll be using, among other things, Streamlit to build the web applications. We'll be using Heroku to host these web applications. While all of these constitute applications and tools that are best in class for specific purposes, Python and Excel will form the foundation of the technology behind the tools in data science course.
So I'll just share a presentation that gives you all an idea of what is going to come in the course. What is the course structure, how you will be evaluated, and all that information. I'll share my screen now. Is the presentation visible?
Yes, Dixon.
Okay. So this is the tools for data science course, and we are here in the orientation session. So this is the course structure. I think Anand, the instructor, would have mentioned all these different modules. And so there are 8 modules that are covered in 10 weeks. So you might have some breaks in the middle, a week's break or 2 weeks break in the middle. That will be structured based on how the course goes. We'll plan that accordingly and inform you later on. So these are the 8 modules. It starts with, first you discover the problem, then you get the data, you prepare the data, you model the data, and then you use some model tools to simplify data, deep learning models, you design your output, and once the output is ready, you try to narrate a story. That is the most important part. It doesn't matter how you actually came up to the output, but once you get the output, how do you narrate it? That is very important. And finally, you deploy the results. So this is what we'll be looking at in the course. Other instructors can chip in if you have something to add here.
I think this part was a bit straightforward, Dixon. Yeah, we can go ahead with the next.
So then the course assessment. So what is the eligibility to write the end term exam? That is nothing. You can write the end term exam. There is no eligibility to write the end term exam. Eligibility for course grade. So you need to have 40% overall score for you to get a grade in this course. And so let's split it up. How do you get the 100%, the split up of 100% marks in this course? 10% goes to graded assignments. So you'll have 8 graded assignments on the portal, and around 10 MCQs are there after each module. And the best 5 out of these 8 graded assignments will be taken. So one thing that you see here is with references and open internet. So this is something that you'll see for graded assignments for ROE, for P1, for P2. This says that when you take up this quiz, in the portal, you will have access to some reference materials for the quiz. And also the internet is open. So you can browse the internet and try to find the answers from the internet. You have access to the internet, use the internet however possible to get the answers. So there is no restriction there for the graded assignments. Then for the remote exam, for the project 1 take home and for the project 2 take home. For all these 4 split ups, these 4 things, you have references and there is open internet. You will be provided access. You can access the internet because the first one is on portal. You can have access to internet. The second was an remote online exam, which you'll have to take from your location. And that also you can access the internet. There is no restriction there. Then the take home project, you have access to internet, and the take home project 2, you also have access to internet. It's only in the final one, which is the end term quiz, and that is in center. So the end term quiz is mandatory. It is in center. And there you only have references provided. So the idea is that you don't have to mug things up. Mugging is not at all required. You don't have to mug the lines of code, and because coding is very important part of the course. Let me explain that to you now. I'll bring this up and we'll also bring this up later on. Coding, Python coding is very important for this course. So in real life also, you will not have to mug up all the syntax. How do you actually write the code, all these lines? You don't have to mug up the syntax. If you go and do a Google search, you can easily come up with the syntax. So that's not an issue. So the same thing is also the same kind of philosophy is here. You don't have to mug up the lines of codes. You have the internet open to you. just go do a Google search and try to find out the syntax and write it. So that philosophy will be followed for the graded assignments, for the remote online exam, for project 1 and 2. But only for the end term exam, you will not have access to the internet. But for your help, we'll actually be providing references. So you don't have to muck things up. You need to know how the code works. That's it. So 10% of graded assignment, 20% of remote online exam, which is around 100 MCQs. I put this around as because it is not exactly 100. It might be around 40 to 100. It depends. So this is not the exact number. Similarly, every graded assignment will not have exactly 10 MCQs. The numbers will vary. Then after the remote online exam, you have the project, 20% to project 1, which is take home project. You get the data sets, you get the questions, and we expect you to post your answers. The same for project 2, project 1 and project 2. So project 1 will be after module 7, and then project 2 will be after module 8. And finally, you have the end term quiz, which carries the highest percentage of 30%. It is in center, and there is no open internet there. You don't have access to the internet. And final score is the weighted sum of each exam score, which is normalized. And to pass this course, you need 40%. That is the eligibility for course grade, as I mentioned earlier. 40% in overall score, that is the pass percentage. And I think other instructors can also chip in if they have something to add here.
Dixon, let me add one more point. As Dixon was mentioning, the entire philosophy of the course is not to teach coding. You will see across the course, while you go through the content of the course, you will see Python coding predominantly appearing in many parts of the program. And instructors would have explained every program sequence everywhere, then and there necessary. The expectation is not for you to understand the code step by step, but to understand how this entire logic works, how different tools are used in this entire data science industry. So we do not expect you to be good in coding, but the basic expectation is to understand how these things work. And it is always a Google away. You can right away Google and find out what this code line explains, or how this code line works. Okay, so no need to panic, or no need to be worried about the coding part of this subject, where the expectation is not for you to become an expert in coding, but the major expectation is to expose you to different types of tools available out there in the market. That way, this course stands alone as a flagship course where you will get first-hand experience of all the codes, all the different types of tools that are being used in the industry right today.
Thanks, Satish. Do we have any other instructors to chip in here?
Yeah, I can just add. Hey guys, I'm Mahesh here. So just to reiterate what Satish and Dixon told, you can think of this course like an internship opportunity in industry, something like that, right? So you will get a very good overview to different types of tools, and you will also get a very good hands-on experience, different cases and problems. But nobody is exactly going to literally spoon feed or let you know what you have to do step by step. So you will know from this course what you have to do when you are given a problem, but how exactly you are going to do it step by step. I mean, the coding mechanics, I don't think that would be the expectation that we will be teaching you that. And I also want to reiterate, it's not an expectation that you know it. And also, even if you try to do it, you will not succeed, right? We cannot literally mug the syntax, or we cannot literally understand every line of a very big coding document. So if you know you want to apply X, use tool Y to solve this problem, that is all the takeaway that you will get from this course. And of course, if you know these two, I think you can solve any problem, right? Because if you have Google, you have internet, if you know what to do and where to find it, I mean, how to do is not exactly a problem. Yeah. Or to other
exactly. Thanks, Mahesh, for bringing that up. To add to it, the entire philosophy is to ensure that you learn how how part, how to do things. So here we do not concentrate more on explaining everything step by step, because that is exactly what you're going to learn here. So whenever we introduce any tool, whenever we introduce any coding sequence or anything like that, please try to do it on your own. Please attempt the same thing, replicate the same thing on your own, so that you will get to know how to do it, which tool to access, when to access which tool. So that is predominantly is what is going to be taught here, rather than explaining everything step by step. And Mahesh has rightly pointed out that this is like an internship. So every instructor here is from the industry. So each one of us have our own expert areas. So we'll be able to expose you right exactly to the industry, what is happening right now. So that way this course stands alone.
Yeah, very well said, Mahesh and Satish. So that was the course assessment. And
maybe just one more minute on this slide regarding the examinations part. So, so when we actually say open internet, it literally means open internet. You are not restricted in terms of accessing any document or in terms of finding resources online in Stack Overflow, in those kind of places as well. So you can use the internet, you can use any reference, and you can use them to support you to answer the exams. And I'm reiterating, the end term will not be open internet. That again is because of the mechanics of it, and not exactly that we want to not use the internet, but just that operationally it's not possible. Except the end term, all other factors will be open internet and open book or anything, any resources that you would like to have.
yeah, thanks, Mahesh. So then the weekly content. So every week you'll have lecture videos on the portal. Then you'll have graded assignments. You'll have the Python notebooks, Excel workbooks, data sets. So in the videos, you'll see that we'll be using different sorts of coding for Python using Python. So those Python notebooks will be made available to you in the portal, and we'll also be using Excel to clean up the data or do other activities, make some pivot tables. So those Excel workbooks will also be available to you in the portal. And then the data sets that we use for Python and Excel will also be available in the portal. And then you'll also have live sessions. So initially we have planned it so that we have one session per week, but if there is a need, we might make it to two. It depends upon the responses from the students, or it depends upon other factors. We'll decide upon that later on as we move into the course. And finally, a very important part of the weekly content is the discussion forum, Discourse. So discussion forms a very important part of anything that you do in life. And also in this course, the idea is to actually make you work as a team. So just as Mahesh also pointed out, it's an internship, and this is a step before you get into the industry. So in the industry, people will be looking for you to collaborate with each other. And discussion forum is one step towards that. It looks at the collaborations that students can get into to solve a problem, to try to address some doubts that they have in the different lecture videos. So if you have any doubts in the lecture, you can post that in discussion forum. You can get answers from other students, or so on. We need that kind of an active discussion in the discussion forum. So that should also be a very important part of your weekly content. And do we have anything else from the instructors to add here?
Yeah,
yes,
the discussion. Yeah, go ahead, Mahesh, please.
No, go ahead. I'll just join it here.
Sure. See, the motive of the discussion forum is to encourage knowledge sharing predominantly. Okay, so and also clarify all the doubts and any kind of glitches that you have over the course. That is given. That is definitely going to happen. Apart from the typical queries, we expect all the learners to engage in a very constructive way throughout this course, to share knowledge, whatever they are going through, whatever the hurdles they they went through when they replicated whatever being taught in the course and everything. We instructors will be online round the clock and ensuring that all the queries are answered on time. There won't be any delay or any glitch in the response of for any queries that is regarding the course. And also, if at all you think the query is not addressed properly, you are very welcome to join the live session to ensure that all the queries are being handled. So we also encourage all the learners to join the live session as much as possible, because in the live session, we typically conduct a lot of quizzes and also mock quizzes. And also we do give out mock exercises as well then and there to ensure that the learners are feeling comfortable with the course. So we highly encourage all of you to join the live session as well, as much as you participate in the discussion forums.
Yeah, just adding to Satish, the same thing that to attend live sessions or do refer to Discourse if you need support, because in the previous episodes we have seen people do needed some support, but they might not be in the live session, or people might need some support in Discourse through live, but they may not be in Discourse. So if you really need support, we are happy to help, but just be engaging with the respective channels so that we can support you guys. Otherwise, no, it will be a bit difficult.
Thanks, Satish and Mahesh. And so the next part is some frequently asked questions. Will we be taught coding? Unfortunately, no. This course is not there to teach you coding, because you must have done coding, Python programming earlier. You must have had a Python programming course earlier. And that is where you must have learned the coding. So we are not going to teach you any coding here. The learning to code is not the main objective of this course. Should we know coding to pass or make the most of this course? Yes. A basic knowledge of Python is required to make the most of the contents being introduced in the course. You definitely need some basic knowledge of Python. And there were some doubts earlier in the earlier sessions concerning Python libraries. So we are not here to teach you all the Python libraries, because you cannot make an exhaustive list of Python libraries. There are hundreds and thousands of Python libraries. We cannot teach you each and every library. Again, this is the intention of this course, is not to teach you coding. It is to make, it is in a way, it ties up all the things that you have learned earlier as an application. So the motive here is to teach you how to apply whatever you have learned earlier. So we're not going to be teaching you coding. We'll not be teaching you Python libraries, because now that you have gone through the Python programming or other courses where you use Python, you must have become proficient to some extent about Python coding. And are there any software requirements for this course? Yes. Access to Microsoft Excel desktop app is required. So Windows version is required, because if you use Mac, then you might not be able to follow along the videos, the lectures that we use, because the lectures are all based on Windows Microsoft Excel desktop app. You might be provided access to Microsoft online app. IIT, your IIT ID might help you get an access to the Microsoft Online Excel app, but that will not help you go through all the lecture videos. There are some lecture videos where the online app is not helpful. It doesn't support some packs in the Excel desktop app. So you definitely need a Microsoft Excel desktop app. And apart from this, access to Jupyter Notebooks, Colab, and some software. These things are freely available. So I think this will not be an issue, because for Python, you can easily use the Colab, the Google Colab, where you can, which you can use to run your Python code. So access to Excel is required, and Windows version is important. And do we get to practice the concepts introduced in this course on our own? Yes, we encourage you to all do this. And Discourse is a very important forum where you can do this. You get to practice the concepts, because we'll be posting some interesting data sets in Discourse. You can use that to practice, to come up with answers, to discuss with your fellow mates and try to come up with a solution. Please use Discourse forum. The data sets will be posted there. And please use Discourse to its full potential. So yeah, these are the frequently asked questions. Anything to add, guys?
This pretty much sums up the major queries.
Okay. So moving on, what are the key takeaways? So the idea here is to give you a fair understanding of variety of tools. So you have a number of tools that are available online. And this course actually gives you an idea of many tools, many open source tools, and these tools are pretty often used in industry. So when you get into industry, you'll find that people are actually using these tools pretty often. So it gives you a very good exposure, and this will eventually help you to easily, maybe if you get used to a particular tool, if you find some particular tool interesting, for example, you have Tableau that is used for visualization. It is very common in industries. If you find that is very interesting, you can dig deep into it, study more into it, and that will actually help you get into an industry pretty easily. Tableau in addition to Python, Tableau in addition to Excel. So these are all pretty commonly used tools in the industry. So this gives you a fair understanding of a variety of tools. And then you get to put into action all the theory that you have learned in other courses. So all your other courses, your machine learning, your BDM, your BA, all these courses will give you a very good foundation of theory. So once you know that theory, this course is purely practical. It is how you apply the theory to solve real world problems. So these will be your key takeaways. And so that's it. Now we'll actually have, I think if we have anything more from the instructors to add.
Yeah, sure. So maybe as I said, a comparison with other courses, maybe let me just tie up some of the courses and tell you how these distinguish from each other and what exactly is this course about. So particularly the machine learning and all those courses will be theoretically very rigorous and very strong. You will learn your foundational understanding in all the mathematics and the theory behind all the techniques, right? So that is about those courses. But in this live session, you had a back-to-back orientation of 3 courses: business data mining, business analytics, and now TDS, tools for data science, right? So these 3 actually are more of applied in nature and a little bit of hands-on in nature, right? So among these 3, if I have to place tools for data science exactly, then first you will BDM, it gives you an overview into problem solving, right, in different domains. So you have 5 different industry like e-commerce, automobile, and etc. And then you had 5 case studies there, and we learned a bit of business domain language, and we also learned problem solving from basics, from scratch, using the most foundational tool, Excel, right? So BDM is a launch pad, and it just sets you guys up towards becoming a data scientist, right? And then it comes BA, which just moves a bit more statistical as well, where you have problem solving, but you leverage a lot of statistical techniques, and you get a little bit more mathematical or statistical, and you do use some tools there apart from Excel, right, like Python. And we do. So what exactly is then tools for data science? So you can think of this as tier 3, where you know by now what are the theoretical toolkits available, and you might have had a fair amount of applied experience, but now you have so many ways of solving a problem. Same problem can be solved in different ways, and you are just confused as different routes are available and which one to take for this particular problem. So tools for data science solves this. It introduces you to a different suite of algorithms, and it also explains you when to use what tool and what are the pros and cons, what are the trade-offs between different tools being used for the same particular problem. So it's like a layer that acts on top of all these courses, which basically garnishes and it aesthetically makes your output or the solution that you try to bring in very appealing. So we are, again, I reiterate, we are not actually teaching you how to code in Python. We are going to tell you this is how things are. These are the things that are available in the industry, and these are the times we have to use it. And on a high level, we will show you a demo of how to use it. But it's like we will give you all the ingredients, and we expect you to be your own chef and cook your own recipe. Yeah, I hope that summarizes.
Yeah, thanks, Mahesh. So before we end this session, I think let's take a few questions that we had. some of the students posted these questions, and I think one theme of questions is based upon how important is coding knowledge for this course. I think we have mentioned that many times. Coding is important. You definitely need to know coding, but it doesn't mean you have to be really proficient at coding. It's enough if you actually have gone through a basic Python course earlier, and that should actually help you to do these coding exercises. But it is fairly important that you know coding, and because many of your Python exercises are based on coding, and we'll not be teaching you coding here. It is up to you to look at the lecture videos and use the Python notebooks that we provide you, because the entire Python notebook is available to you on the portal. You can play around with the Python notebooks that we provide you every week. You can play around with that. It is exactly as it is given in the lecture videos. The same notebooks are available. You can play around with the Python. You can discuss, you can raise queries in Discourse, discuss this among your fellow students and try to come up with solutions. So coding is fairly important, but it is not important. It is not so important that you need to be really proficient at it. As this is just a part of your learning, this course will also help you enhance your Python coding levels to another level. And then,
yeah, I would like to add one point here, just to be consistent in this point. And also, we are not really going to score you or evaluate you based on your coding syntax or the way you code. We give you a problem and we ask you the solution. You are free to use any toolkit, anything totally, and give us the solution. So we are not going to evaluate you on how you arrived at the solution, but we are just going to evaluate you at the final solution you are given. So coding is not even part of your evaluation as well.
Yeah, that's right. And it is just like this is how it works in the industry. If you're in the industry, you're not required to, many of the people in industry are not proficient with coding. But the way things work is that you have an idea of what you need to do. And once you have an idea, you have Google. You can just search for the syntax, apply the syntax that is available in Google. There are many pre available solutions that are there in Google. Just take that up, make some changes and try to get the solution for the required problem. That is how things work even in the industry. So this is just a precursor for you so that you might be able to adjust well in your industry. And then the other theme of questions that we had is based on, can I take TDS before MLT, MLP? Is there any preferable dependency for TDS with any other subject? So the main dependency would be Python programming. You should have known Python programming, and also TDS is, I think, MLF is a core requisite for TDS. So TDS uses some parts of machine learning. So it is really important that you know some concepts that are being taught in your machine learning, concepts such as regression, and we talk about correlation and other very simple machine learning stuff. So we might be talking about some deep learning or neural network models. We will not be using those models as such as they are being taught in machine learning. Machine learning is purely about the nuts and bolts of each and every algorithm. So we are not going into that. Here, the algorithms that we use, the regression, the neural networks, they are all just a black box. So it is not important that you know these algorithms very well. You can also learn them as you go through this course. But programming is really important. And also machine learning foundations is a core requisite. So that is also helpful when you take up this course. Other instructors can add things to what I said.
Yeah, that was a good summary. Yeah,
okay. And I think these are the two main themes of questions. And do we have any other questions? If I don't have access to Microsoft Excel, can I use Google Sheets? You can use Google Sheets, but then if you want to really follow the lectures and apply whatever is being told in the lectures, Google Sheets has a different style of applying these things. You can work these out even in Google Sheets, but the questions that are being asked the questions that are being posted in the graded assignments or the questions that are being asked in your remote online exam, in the end term exams, will be based on the Microsoft Excel. So Google Sheets is a good way to get to know the tool. You can work things out in Excel and then try it out in Google Sheets as well. But Excel is really important because all your questions and all your exam questions and all the lecture videos are based on Microsoft Excel. So what are the prerequisites? That is a core requisite for machine learning foundations. That is the core requisite. There are no prerequisites, but Python programming, we could say, is a prerequisite because you need to be proficient and you need to have a basic knowledge of Python. So there are no more questions. Do we have the instructors? Can you, if you have something else to add, we can add and then we can close the session.
You clearly summarized it, Dixon. That's all from my side.
Okay.
Thank you.
Thanks, Satish. Thanks, Mahesh. And we have also Prasanna, one of the TDS instructors. Thank you all for joining. Do we have anything else from the BDM or BA team to add? Sukrat, Swaminathan? Okay.
Yeah, I believe that's a no. Yep.
Okay. Thank you, guys. Thank you all for joining this session. Have a great time learning. And we hope to meet you soon in this course and have a great time learning and discussing things. Thank you.
Thank you.
Okay. Bye-bye. Thank you.
Bye.